Hey guys, I completely forgot to record this in class. I'm recording it after school. But these are the notes for the volume lesson that we did in class. So starting with slide number 2. So the first thing we're doing is we're identifying these shapes. So our first shape here is shaped like a tissue box. A lot of people in class told me it was a cube, but it's actually a rectangular prism, okay, when the sides are rectangles. Our middle shape here is a sphere, like a basketball or anything round. And this last one is a cylinder, like a Coke can or a can of soup. Okay, slide number 3. This first one is a pyramid. The middle one is a triangular prism. And this last one is a cone. Okay, so slide number 4 has the clips from our star formula chart that we're using today. So the star formula chart, I've given you copies of it before. If you need another copy, just let me know and I can send it to you. But we will be using the section called area and the section called volume. Okay, slide number 5. So a couple of definitions. So volume is the amount of space enclosed in a solid figure. So we're talking about 3D shapes today. So not like drawing a triangle on a piece of paper, but a 3-dimensional shape you can hold in your hand. And the volume of a solid is the number of cubic units contained in the solid. So if I'm measuring my, rectangular prism in inches, it'd be inches cubed. Okay, slide number 6. So we have this little green alien guy here. It looks like he's screaming, but he's actually singing. So y'all know that song, All About That Bass? It's by Meghan Trainor. So finding volume is a lot like that. It's all about the bass. Okay, so we have 5 steps here. So step 1, identify the shape. Is that a sphere? Is it a cone? Is it a rectangular prism? Figure out what it is. Step 2, identifying the base. So like the base of a triangular prism would be a triangle. The base of a cylinder would be a circle. 3, draw the base separately. 4, find the area of the base. And 5, multiply the area of the base times the height of the prism. Moving on to slide number 7, has these orange boxes. So we're going to define some terms here. So the first one is base. This is the ends of the figure, not always the bottom. And in a triangular prism, the base is, a triangle. Okay, I'm going to stop sharing my screen just for a second so I can show you this triangular prism. Okay, so say triangular prism has a triangle on 2 ends. The other sides are rectangles. Looks like this. So I know in other classes, and your brain might think base and think, okay, that's the bottom of it. If I'm holding my triangular prism like this, the triangles are on the top and the bottom. Totally agree. But if I'm holding my shape like this, my triangles are on the left and right side. So they're not on the top and the bottom. So our bases are the ends of them, whether I'm standing it up like this or holding it sideways like this. Okay, our base are the ends. Do not think of base being the top and the bottom because that is incorrect. Okay, I'm going to go back to sharing my screen now. So the height of the prism, I know we're thinking, Ms. Ray, I get it. Like I know what height is. It's a little bit different when it comes to volume. So height is the distance between the bases. Okay, so I'm going to stop share so I can show you my image again, my shape. So we're used to picturing height as our up and down distance, right? How tall it is. And if my bases are on top and bottom, that is what it is. It's the distance between the triangles. But again, if I hold my shape sideways where I can have my triangles my left and right, the height is actually this distance. It's between the 2 triangles, okay? Picture it like a tall building that fell over, okay? The height is this distance. So we're going to use that a lot. Height of the prism, know that it's the distance between the bases. And last one is cubic. It means 2 to the 3rd power, and it is the units used for volume. I can show you like example inches cubed or centimeters cubed. Oops. The way I'm getting this exponent in here is if you hit control and then the decimal button or control and the period, it will pull you up into the exponent and you can type it there. Okay, going to slide number 8. So we have a shape here up in the top left-hand corner. My instructions say, first thing, what is the name of this shape? This is a rectangular prism. So what shape is the base of a rectangular prism? Not a trick question. It's a rectangle. And what formula should we use? So you're going to get your handy dandy star formula chart. Okay, and you're going to go to volume. So my options are prism or cylinder, pyramid or cone, and sphere. Those are your choices. So this falls under the prism or cylinder category, which is V equals big BH. Big B meaning capital letter B. That's super important because capital letter B and lowercase b mean two different things in this unit. So this is big B times H. Okay, so I have my rectangular prism down here. My side lengths are 4, 3, and 6. This darker blue square is just the base drawn separately so I can view it. Now the rectangular prism is a little bit special because it doesn't matter which side you pick as the base because all the sides are rectangles. Okay, on a rectangular prism, every single side is a rectangle. It's not like a triangular prism where just two of the sides are triangles. So I'm going to pick the bottom as the base just for my example. Okay, so what is the formula for area of a square or area of a rectangle? So I'm going to look at my star formula chart and I'm going to check it. And I know that area is equal to lowercase bh, base times height. So now we're going to actually solve this. Let me just go ahead and write it on my whiteboard so that way we can look at it together. One second, my camera's not connecting. Okay, sorry guys, I had technical difficulty, but I think I figured out a way around it. Zoom won't let me use my document camera and my desk camera while I'm recording, but I was able to pull up this whiteboard. So here was our shape. I know it's not the best in the world, but I'm doing what I can do. Remember our volume formula was V equals big BH. V equals big BH. Big B stands for area of the base. Area of the base. So area of my base, well, my base is a rectangle. So that means I need to find the area of the rectangle. So 4 times 3, so that's our base times height. So 3 times 4, which is 12. So my big B is 12. Okay. The height of my shape is 6. So multiply by 6, and 12 times 6 is 72. So the volume of this shape is 72. 72. Okay, so there is a shortcut way to solve this. I'm going to show you how to do that. And you may hear me call this the 5th grade method because you did learn how to do this in 5th grade. You just might have forgotten about it. So this only works for rectangular prisms. And I'm going to tell you right now that this shortcut method is not on your star formula chart. I am totally okay with you using it, but you need to just memorize it because it's not something that's going to be given to you. But we can find the volume of a rectangular prism by doing length times width times height. Okay, and so that's an L, not an E. But that would be 4 times 3 times 6. which also equals 72. Okay, so you get the same answer. If it was inches, it'd be 72 inches cubed. If it was centimeters, it'd be 72 centimeters cubed. I didn't give units in the problem, so we don't need to worry too much about that. So if I go back to our slides, the one thing we haven't filled in is the area of the base. The area of the base was 12. Okay, going on to slide number 9. Okay, so on this slide, we're on slide number 9. First off, what is the name of the shape? So it has triangles on the top and bottom. You should know this is called a triangular prism. What shape is the base of a triangular prism? Not a trick question. The base is a triangle. What formula do we use to find the volume of a prism? So I'm going to check my star formula chart. The formula is V equals big BH. Oops, I don't know why it's formatting that way. That's so strange. So moving down, we see the image of our triangular prism. And then next to it, I drew the base, so just the triangle. I'm going to fill in my numbers. So the bottom part of that triangle is 10. The height is 4. I don't need to worry about the 6's there. Those are just there to confuse you. The formula for area of a triangle is, so check your star formula chart if you don't know it, but it is 1/2 BH, lowercase b. So I'm now going to show you my whiteboard. And again, I'm sorry I can't use the document camera. I don't know what's going on, but this is going to have to do. So we have our triangular prism here. Formula is V equals big BH. And then I have our triangle drawn in red. The area is 1/2 base times height. So my area is going to be equal to 1/2 10 times 4. And that is 20. 10 times 4 is 40, times 1/2 is 20. So my big B is equal to 20. Then you need to multiply that by the height. So I'm going to look, my height is 5. So 20 times 5, your volume is 100. Okay, there is a shortcut method for solving this, similar to the one for rectangular prisms. Remember, rectangular prism was length times width times height. So I'm going to show you something real quick. This isn't going on your notes, but just so you know. So a rectangle has a base and has a height. The area formula for rectangle is just base times height. If I split this in half diagonally to make 2 triangles, the area of just one of these triangles would be 1/2 base times height. That is why that's the area formula. So this also works with the volume formula. So if the volume of a rectangular prism was length times width times height, then the length times width times height, then the volume of a triangular prism is length times width times height divided by 2. So I could do 5 times 4 times 10 divide by 2, and I would get 100 as well. Now, this is not on the formula chart. It's just something you got to know. Okay, I'm going to call it the shortcut method or the 5th grade method. If you hear me say that in class, that's what I mean. Okay. Going to our notes. The area of our base was 20, so we go and fill that in. Okay, now go to slide number 10. This is all about circles because we're about to do cylinders, and cylinders have lots of circles. So circles, the measure all the way across, like the middle of a circle, is called the diameter. The measure from the outside of the circle to the middle of it, just like part of it, is called the radius. And the radius is half of the diameter. So if our diameter is 10, our radius is 5. Our diameter is 20, our radius is 10. Going on to slide number 11. So first of all, what kind of shape is this? It is a cylinder. What shape is the base of a cylinder? It is a circle. And what formula do we use? So I'm going to look at my star formula chart. Formula volume, or prism, or cylinder is V equals big BH. It's almost like Miss Ray knew what she was doing, and she put all the ones that use the same formula grouped together so that you could get lots of practice. Almost like I knew what I was doing. So our base here has a radius of 7. Remember, radius just goes halfway to the middle. So our formula for area of a circle. So this one you might need to consult your star formula chart. It's not one that you might recognize right off the bat, but it's area equals pi r and then squared. I'll make that bigger. I got the pi button, the pi symbol just by, I went to Google and I Google searched pi and then I copied and pasted it. You could also do insert special characters and find it that way. So pi r squared. Pi is just a number, so don't get confused about that. But the area of the base. So now we're going to solve for the area of this circle. Before we do, though, I need to show you where the pi button is on your calculator. So if you are a virtual student, the pi button on your calculator, you look right here, it's this purple arrow where it's pointing. So this button that looks like kind of like the roof of a house, if you notice written right above it in blue is pi. Looks like a table with only 2 legs. In order to get anything in blue on your calculator, you got to push the blue button first, where the green arrow is pointing. So you push the blue button, the second, and then you push the button that's right above division, and that'll get you pi. Okay, if you are a classroom student, the pi button is in the bottom left-hand corner of your calculator. It's next to the letter H down on the keyboard. Okay, can't miss it. And if you need me to show you that, please speak up and I will certainly show you how to get there. Okay, so we are going to find the volume of this cylinder. So it's very hard to draw circles with a mouse, so I apologize, it looks terrible. So our volume formula is volume equals big BH, okay? So big B stands for the area of the base. So that means we need to find the area of this circle. So area equals pi r squared. That is the formula for area of a circle. So we're going to use the pi button. So it goes pi, r stands for radius. This is something that, like, if you see that my 7 right here is only half the circle, so I can use 7. So I'm going to put 7 right here. If you were given the diameter, you would need to divide it by 2 in order to find the radius. So you're going to type pi 7 squared into your calculator, and you're going to get 153.938. Okay. So that is what the area of the circle is. We're not done yet, though. That is not the answer. So volume is the area of the base, which is 153. I'm going to say 0.9 and just round it. And then we have to multiply it by the height. So if I look, my height is 8. My height is 8. Okay, so I'm going to do 153.9 times 8. And your final answer is 1,231.2. And that's what your volume is. If I go back to fill in my notes, the area of my base was 153.9. Okay, so the next slide was just about the calculator, again, how to find pi. Remember, it's all about that base. So it's all about finding the base of the shape. So if it's triangular prism, finding the base of the triangle. If it's rectangular prism, finding the base of that rectangle, or a cylinder is a circle. The 6 shapes that we started a class with, those are the only 6 shapes we're going to be working with. I'm not adding anything else, dodecahedrons, octagonal prisms, nothing like that. Just those 6 shapes. So we're done with the notes today. Do not hit submit. There's some more practice problems, which I will make videos for at a later date, but we are going to add on to these notes next time we have class. So don't hit submit yet. They're just going to live in your Google Drive for a little while, a few days, and then when we add on to them, you can turn them in then. Okay? Reach out to me if you have any questions.